Hello, Internet, and thank you very much for joining us on the cloudnative.fm podcast. And today is a big day for me because first time in my channel we are talking about Flux, and what a favorite moment can there be is Flux is now a CNCF graduated project. When Weaveworks donated Flux and Flagger to the CNCF, Flux maintainer noted large scale adoption growing and Cloud Wonder making the Flux suite core of their offering to provide GitOps functionality. And today is very exciting day for this channel as we will go back in time with Flux core maintainer who have worked on Flux for more than 5 years for a tour of the first keystroke to the creation of Git repo and is now a graduated project in the Cloud Native Computing Foundation, joining the ranks of Kubernetes, Helm, Prometheus, and others in this category. So let me introduce my audience to you, my guest to you, Stefan Prodhan. Thank you very much for joining on the show. Now, stage is yours. And now, quick introduction of yourself, and then we start the journey.
Hello, everyone. Thanks very much, Saim, for inviting me. I'm very happy to share with you the history of Flux. Flux, the continuous delivery system, not Flux, the other things, because there are many Flux things out there. Anyway, I'm a principal engineer at Weaveworks. I'm working there for around almost 6 years now, 5 years and a half. And my job at Weaveworks is to contribute to open source projects in the cloud native ecosystem. And I'm a Flux and Flagger maintainer since I joined. So that's about me.
Thank you, Stefan. It's been a wonderful introduction, and it's what better feeling we have to meet a person who have worked for this awesome project over the year for a very long time. So let me share the screen, and now you can tell us your journey into being into the what happens over the years from incubation to sandbox to incubation to graduation. So I'm just sharing your screen and now everybody can see the screen and now
Cool.
the party time start. So Stefan, let's
Cool.
go back in time.
Yeah, so Flux started many years ago inside Weaveworks as a way of making deployments easier for the current team. So let me show you how um, deployments look like. So first, the Flux V1 definition. We called it a DevOps tool that automatically ensures that the state of a cluster matches the config in Git. It's quite meta. So to explain this and how GitOps came into being and everything, I will start with a slide that I know everybody probably have seen this kind of diagram, not only applied to Kubernetes, but we do deployments like this for many years. You have your code in a Git repository. You have some configuration of how your code gets deployed. And once you commit that code, there is a CI/CD pipeline, a tool, let's say Jenkins or SAS like Circle CI and so on, that reacts to your new Git push, does some things. Let's say for Kubernetes back then, we had a bash script that was doing a Docker build, then was fiddling a little bit with YAML. It was changing the tag in a Kubernetes. It wasn't a Kubernetes deployment. It was a replica controller. So it would do some changes inside the configuration. Then it would connect to a particular cluster and then run a kubectl apply on that cluster, right? This is how most legacy continuous delivery system looked like back then. So this was the year was 2016 when we had this type of deployment. And back then, Kubernetes was very new. There were no Kubernetes as a service. We were running and we are still running our infrastructure on AWS. So the issue with this approach was that every time we add a cluster or we change something inside the cluster, we had to, regenerate a kubeconfig, which has all the secrets on how we can connect to the Kubernetes cluster in production. And then we had to put that Kubernetes config in our CI system as a secret, right? So we wanted a better system in a way that leverages Kubernetes itself. Kubernetes is quite different from all the other things that were before it in a way that Kubernetes is declarative. And second of all, Kubernetes maintains its own state. So we don't have to, like with Terraform and other tools, we don't have to maintain a third state to track changes. Kubernetes itself has a database, which is called etcd, everybody knows, and in there, the whole state of the system is described. So what we try to do in Weaveworks is leverage this Kubernetes feature and try to make the clusters be aware of changes. So instead of going out to the cluster, connecting to the cluster should be able to monitor an external system and decide, I have to perform a change. Something changed in there in my desired state. So I'm going to, apply that state to myself. And this is how Flux was born. So the change was, instead of, having this CI/CD tooling outside the cluster, connecting to all the clusters to apply changes, we extend the cluster with a process, a daemon called Flux. And Flux from inside the cluster reaches out outside to a Git repository, and it fetches the new state of the cluster and tries to reconcile the cluster with its state. The main difference between the two approaches, beside the philosophical approach of push versus pull and all of that, the main difference is that once the cluster is self-aware and can reconcile itself, it can also detect drift and correct it. A thing that you can't easily do with an outside system. What drift detection and correction means? Let's say you describe your app and you say, I want to deploy my app at version 1.0.0, right? And you run that through your CI pipeline, you do a kubectl apply, and that version gets deployed. Now, let's say during an incident, someone gets directly on the cluster and modifies the version by hand. Or it does not only the version, maybe it does config changes and so on. How do you know now at which state is your cluster? Someone from your team at some point made a change there. One way to do it will be to, rerun the CI job, rebuild your app, deploy it, and then you'll probably revert some of the changes, but you are still not aware of all the changes that happen during an incident on your cluster. With a tool like Flux, something that implements GitOps, the idea is that the cluster should detect these kind of changes, which are made outside of the desired state, outside of Git, and try to correct them, or at least alert that, hey, my specification is that I should deploy this app at this version, and another version is deployed, right? First, it should be aware of that, should be able to detect it on its own, and then it should also be able to correct it, roll back any manual changes, and apply the last desired state, right? So that's what Flux was made for. We wanted to, create clusters, bootstrap them, install Flux on them, and then we tell Flux, hey, synchronize with this repo, and that's it. From that moment on, we don't have to connect to the cluster anymore. All the changes can go through Git, using the well-known road of driving changes with your peers in a pull request, with reviews and so on, right? Not by connecting directly to the cluster and applying whatever you have in your local machine. So the idea behind Flux is that basically it extends the cluster to be able to reconcile itself from the desired state, which is the Git repo. But this also enables collaboration of humans over infrastructure and over app deployments and so on. And it's the same type of collaboration you have while developing applications, right? You extend that. What are you doing there? What processes you have? You can extend those procedures to actually running your application in production, which I think it's a different mindset from what we did before, but in a good way, right? We are trying to unify how we think about configuration. Configuration should go through the same routine, configuration changes to the same process as code changes. And with microservices rising and all of that, deployment and being able to ship fast is one of the forces that drive innovation and so on. And Flux tries to simplify that. So this is what we had back then in 2016. There were some limitations to that, to Flux version 1. One of the things was, back then there was no Kubernetes custom resource definitions, for example, right? So it was hard to observe what's happening with a continuous delivery system that's running your cluster. The best way to do it back then was tailing logs, for example, right? You have to ship all the logs outside of your cluster and look at the logs and see what Flux is doing. We also added a command line tool to it and so on. But the design of Flux version 1 was such as one cluster can follow a single Git repository and a single branch from that repository. So it forces you in a way to use a monorepo for everything that you deploy in a cluster. And back then we felt like it was a good design because there weren't custom resources and so on. It would kind of made sense to put all your apps together. Over time, things changed, of course. And now I want to switch to the people behind Flux version 1. Back when it started, it was Alexis Richardson, which is the CEO of Weaveworks, Michael Bridgen, which was one of the principal engineers in Weaveworks. Now he's working at Pulumi. Peter, Paolo, there were like so many people working on Flux version 1, and how the GitOps term came into being. So the team built Flux. It was called Fluxy, I think, the first ever version. And there was an incident. Someone by mistake wiped our production cluster on AWS. That person was working on, I don't know, an Ansible script or something like that. The cluster got wiped. They realized, okay, our production is gone. They rebuild the infrastructure, and they have redeployed Flux, and in a couple of minutes everything was back online. And Alexis was inquiring, like, how did you manage to get all these things back? And the explanation was, well, the cluster took its state from Git and it recovered itself, which was how Alexei came with this term of Git ops, where you drive operations through Git, of course, and that's how the term was born. Now GitOps is no longer something that is only about Flux. There are so many GitOps tools, and yes, people took the term and made whatever they want from it. So even, I don't know, running something like GitLab runner, it's GitOps now or whatever. But back then, GitOps was kind of an internal word. It had a very clear meaning. It meant that the cluster, which was a Kubernetes cluster, could fetch its state from Git. And yes, that was that was how all started. A little bit of a timeline of version 1. So Weaveworks made it open source in 2016. We very fast observed that, now that everything is in Git, what happens if I want to deploy an app on the staging cluster 10 times per day? I'm going to, commit the source code, the source code changes. There will be a Docker build process, and then a new image is pushed to Docker Hub, right? But then I have to go into my Flux repo, and I have to manually change the version of that container image because I've deployed a new version, right? And this was like, okay, we have this great automation that looks at Git, but now it's on us every time we build a new image to go into Git and manually change that. And it's a churn, right? It's a thing people don't like doing repetitive things. So what Flux gained almost instantly after we released it was the feature of scanning container registries based on a policy. Let's say on staging, I want to deploy pre-releases using a Semver expression or things like that. And what Flux was doing was scanning the container registry, and when it found a new image to deploy, instead of modifying the cluster state directly, which most CD tooling are doing, Flux was modifying the Git repo. So Flux first would scan the container registry, will find the new version, then it will clone the Git repo. It will find where that version is referenced inside, let's say, a Kubernetes YAML. It will modify the YAML locally, and then it will push the change back to Git. Then the other side of Flux will see, oh, there is a change in Git, let me apply that. So why is this so complicated workflow? The idea behind GitOps is that any kind of change to your cluster must be in Git. So you can use, for example, Git history as an audit tool for everything that happens in your production cluster. So if we can't bypass Git for this type of changes, if we need to deploy a new app at a new version, that thing has to go first in Git and only afterwards in cluster. So, and image automation lives on. It's also now in Flux version 2. It's more capable. In Flux version 2, you can update not only a Kubernetes deployment, but also custom resources that have images in there, OCR artifacts, and so on. But this was one of the features that made our life in Weaveworks as, engineers and SREs better, because we didn't have to, go there and manually update things. After a year, we made our first general available release, so Flux 1.0.0. Then we had some traction with Flux. We went at KubeCon. KubeCon back then was, small, nothing like today. We started preaching the GitOps way. People were like, oh, what's this GitOps thing, and so on. Alexis did a bunch of talks. I joined Weaveworks in 2016. Then we went to KubeCon Copenhagen, I think, and we did 2 talks on Flux back then, and that's where more and more people started to, be interested in Flux and adopting Flux. We soon figured out that, okay, but if you don't have to expose your Kubernetes API to the internet to have this CI system connecting to it, to deployments, your Kubernetes cluster or production cluster is way safer, right? You don't have to expose the API. So that adds a bunch of security. But what happens if someone takes over your GitHub account or your GitLab account, right? Then it has access to the Git repo where Flux is listening and can do whatever on the Kubernetes cluster. You can deploy whatever thing in there by, doing a commit. So how we thought about securing the pipeline was by verifying commit signatures, and this was basically the first security feature that went into Flux. The idea is even if someone hacks your GitHub account and does a commit for you, it cannot sign the commit with your private key because your private key is not stored on GitHub, only your public key is, right? So Flux will not look at GitHub to fetch the public keys. Flux expects for the public keys to be in the same namespace in a Kubernetes secret. When you deploy Flux, you also create this a Kubernetes secret with the public keys of all the persons which are, allowed to change the cluster state in production. Your, on-call team, your developers, and so on. So what Flux early on was able to do is when it see a change in Git, it will pull the change, then it will verify that the commit is signed by one of the approved signatures. And a lot of people got excited by this, and our user base grew because of this feature. Now, after 4 years, we have moved beyond OpenPGP, and now Flux version 2, for example, is capable of verifying the authenticity of OCI artifacts, not Git commits, with cosign, for example, using quite the same procedure. And cosign has also a tool that allows you to sign Git commits, and we are looking at maybe next year, extending the Git commit signature to cosign as well. But I think security tools evolve over time. OpenPGP was the solution back then. Everybody, that was the only way you could sign things. But I think we should move to new tools and embrace the future and not be stuck in the OpenPGP world and try new things. So that's why we've this year we've integrated cosign in Flux. And I'll talk later on about that a little bit. In 2018, Kubernetes CRDs were a thing. Kubernetes made available custom resource definitions, and it was a different paradigm on how you can write automation on top of Kubernetes. And Flux back then was able to work with, plain YAMLs, plain Kubernetes manifest, which you would put in your repo. But Helm was gaining more and more traction. So we attended the first Helm Summit in United States, and a lot of people were interested in GitOps, but they wanted GitOps for Helm and have a Helm story to that. And while there was quite an easy way of doing things with Helm, where you run Helm template and you'll push all the resulting YAML to your Git repo and apply that with Flux, or other GitOps tools out there are doing this thing where give it a chart and they just run a Helm template. The feedback back then was that people wanted the whole Helm experience. They wanted, to be able to list releases. They wanted to see the history of releases. They wanted to roll back releases. They didn't want just, rendering the Helm chart, apply it, and that was it. They also wanted to have control over, the Helm hooks, being able to run jobs before, after, during upgrade, and so on. So that's when we started thinking of a solution that embraces Helm from an operational point of view, but is declarative. You don't have to use the CLI. So That's when we introduced the first custom resource definition into Flux, and the first operator we wrote. But back then it was called Helm operator. It was a Flux add-on, and we came up with a custom resource definition called Helm release, where you had all the CLI commands available, but as fields in a structured YAML file. So you could tell Flux how to install a Helm chart, how to upgrade, how to roll back, and so on, through in a declarative way. And then on the server side, this operator, the Helm operator, instead of using the CLI, shelling out to the CLI, we have worked with Helm upstream and used their SDK. So Helm, the CLI is built on top of Go packages, right? It's made out of Go. Flux is also written in Go. So we use the packages in the same way that the Helm CLI did. And the result was you could deploy Helm releases, roll them back, whatever. But then if you need to debug them, you could do Helm list, Helm view, Helm rollback, and all these things. So after that, Flux took off. After we had the Helm release, the Helm community embraced the GitOps idea, and our user base grew enormously. We also on that year, Weaveworks donated Flux to CNCF. That also we went into the sandbox, and more and more people were aware of the GitOps thingy called Flux. And from there on, we had an avalanche of feature requests, new contributors, companies that wanted to deploy Flux as part of their platform, and so on. Also, Microsoft was working on their managed service, and they were looking at the tool that automates deployment and so on. And we collaborated with them back when Flux was version 1 on that. Also with AWS on EKS when EKS became a thing. So Flux was growing, and we started to add more features to it. One of the things that we did after Helm was adding customized support. It wasn't perfect. It had many issues. We had to shell out to customize to, we called it manifest generation. So basically we allowed people to write scripts in their Git repo, and Flux will execute some part of those scripts in its container. And from a security perspective, that doesn't sound very sane, but that was our approach back then to add customized support. Later on, we implemented garbage collection. This was a feature requested from the beginning. Was the idea of garbage collection in a GitOps pipeline? When you add a deployment or you modify a deployment in your Git repo, Flux will reconcile those changes on the cluster. So it will add those fields or remove fields from an existing object. But what if you you delete files from the repo? How Flux can determine that, at some point I've deployed some stuff, now they are not part of the desired state, but I was managing them before, so now I have to delete them. One approach to this was scan the whole cluster, and whatever is not labeled at Flux, delete everything, right? But then you would delete core DNS and other things that come at cluster bootstrap. So you cannot just look at the cluster and say, oh, if it's not created by me, I'm going to delete it. Now we have owner references and other things inside the Kubernetes cluster, and maybe today would be easier to determine who created what, but back then it was almost impossible. So what we did was we annotated things with checksums, then we queried them and determined, if this checksum changed, then it was part of the previous apply set, now is not, and I'm going to delete it. So that was the first ever version of Flux garbage collection. It was kind of heavy on the Kubernetes API, but it was a feature highly requested. So in Flux version 2, we've completely rewrote the how garbage collection works, and it's kind of stateless now. It doesn't have to query the API, it just knows, because now we have custom resources and we can add data on their status. So what in version 2, what Flux does, it compiles an inventory of things that Flux manages on the cluster. And once things are removed or added to the inventory, that's how we delete or change things inside the cluster. But back in 2019, garbage collection was a great feature back then. And the last major feature that we added to version 1 was secret decryption. GitOps is great and all, but at some point you have to create secrets, and placing secrets in plain text in your Git repo is nothing but secure, right? Kubernetes secrets are base 64 encoded, so they are not encrypted with anything, right? So if you place a secret in your Git repo, even if you can't read the actual values, they are just base 64 encoded. So that's definitely not encryption. So there were tools like Seal Secrets back then and others, which allows you to deal with secrets, but we felt like it's a chicken and egg problem in the end. If Flux is the first thing that you deploy on your cluster after you create the cluster, and for Flux to synchronize changes, it needs to read the secret to connect to the Git repo, for example. It needs to read the SSH private key. How Flux can configure some secret manager before that? It can't, because the seal secrets or whatever it is, that definition is in a Git repo. So people had to install seal secrets with Helm before they install Flux. They have to configure it, then allow Flux to take over that installation. So it became very complicated, the whole Bootstrap experience. So we thought that we need a way to natively be able to decrypt secrets. So we chose Mozilla SOAPs, which is a CLI made by Mozilla Foundation. They use it internally, and is not only made for Kubernetes, it's a generic CLI that can encrypt any kind of configuration file. What's nice about it, when you give it YAML, it can only encrypt the values and not the keys. So when you look at the Kubernetes secret, you actually see the keys, so you know that, okay, this is an SSH private key, this is a token, but you can't actually access the value unless you have the private key to decrypt it. So what we did early on back then, we integrated with the SOAPs project. SOAPs is also written in Go, so it was easy for us to import their libraries into Flux and work with that. And this feature lives on in version 2 as well, and we improved a lot the secrets decryption procedure in Flux. Flux now can work with KMS providers, so you encrypt your secrets with I don't know, Azure Vault or HashiCorp Vault or Google Cloud KMS and so on, and then so that's on the CLI, and then on the server side, you assign Flux a role binding, which has access to read the public key for decryption, and that's how it works today. So it's more cloud native than it was back then, when it only worked at start with OpenPGP, but now we've extended to all the SOAPs providers, all the cloud KMS are supported, and so on. And things were started to not be great, let's say, in terms of contribution. It was very hard to contribute to Flux version 1 on that year. The code base was becoming quite huge, and version 1 was a monolith. It was all the code was in a single repo. Everything was there. You had the code that was doing Git cloning and all the Git operations in the same place with the code that was applying things, with the secrets and so on. It was kind of mixed together. Also, back when we started Flux, we didn't know that Kubernetes will be the only way to do deployments. Back then, Docker Swarm was even more popular than Kubernetes. So Flux source code was written in such a way that at some point we would be able to add more orchestrators, and of course that came with some complications in how Flux was architected. So in 2020, in winter, me and Hide, a colleague of mine, also a Flux maintainer, who was working on Helm operator back then. He wrote basically the whole GitOps for Helm part. We were thinking about how can we, how can we split the source code? How can we make it easy to contribute? How can we create different repos, maybe packages, and so on? And we were looking into kube builder and controller runtime. These are some the SDK and a CLI made by the Kubernetes team for people that want to develop controllers. And it was a new paradigm on how you can build controllers and so on. So what we've done is we thought about splitting up Flux version 1 into many pieces and create these specialized controllers. So for example, all the Git operations should be made by single controller, and that controller should only do that. And installing and upgrading Helm charts through Helm releases, that should be a dedicated thing. The thing that applies, manifests, or builds customized overlay, that should also be a separate thing, and so on. And this separation took us to Flux version 2. Before skipping to Flux version 2, I want to show you what the final version of V1 looked like. So this was the whole schema. Flux, it was a single container, a single deployment that connected to the Git repo, could write to the Git repo, read to the Git repo, also would connect to your container registries, will pull image metadata from there and store it in a memcache deployment next to it. So we use memcache to store all these things. And that's how version 1 looked like. Now, let me tell you about version 2. Do you have any questions, Saim, about what I've said until now?
No, it's been wonderful. Like I think like during, as you mentioned, when you started, there is Kubernetes is actually battling with GitOps or battling with Docker Swarm, and you guys come up with the terms called GitOps. I think a lot of the technologies went into the room where Alex is doing this GitOpsy thing first time and see what it is. And on that time, I think things are really complicated. As you mentioned, there is no CRDs, and people don't think about on that point in Kubernetes. You can extend Kubernetes to build some new advancement on top of it, but there is no CRD. But still, Flux is getting momentum, working with secrets. There's a Helm chart, customized overlays. So I think a lot of effort went into it. That's make the Flux 2 a more kind of a generic and easier to use tool because of all of those learning environment as well. But as like before we go to the Flux 2, what is the hardest part? What is the hardest part for the Flux V1? Like, there's a contribute very less people contributing to it, plus we have a secret that if you're talking with the people on that time, you have everything set up using GitHub, and people like to think about, where do I store my secret? is not be in the in the GitHub, what are the different strategies you could take? But all of those what you drive the conversation forward. What do you think is the most hardest part for the Flux V1, and what thing your mind kick in to convert this into the entirely to the Flux version V2? So, uh, what is the hardest part?
So the hardest part in version one was the fact that we relied on CLIs to do all things. We rely on the Git CLI to connect to the Git repo, clone the repo, and so on. We rely on kubectl, right, the Kubernetes CLI to apply things. And CLIs are written for single use, personal use, someone executes something, right? And they are not written in a way that they are, let's say, uh, easy to make things in parallel, to parse their result, understand their result, and report the result later, and so on. So we were like dealing with, oh, Git logs this stuff, and oh, this thing should be private. We can't, if you inline the username and password, if you, let's say you do an HTTPS connection on Git and you have username, Aaron, password, and the Git, we can't let that being logged into Flux, because then we'll divulge the Git password. Another hard thing was we had to mount all the SSH keys into the Flux container. So they are on disk for the Flux CLI to pick them up with SSH agent and so on. So working with, building automation on top of CLIs, it's terrible. That's my whole experience with it. You can't even think about multi-tenancy if you do such a thing. For example, if you exec to some CLI and you give it some input, which is created by a tenant on your Kubernetes cluster, you have absolutely no control of what can happen. That tenant for sure can do a directory transversal or stuff like that, and have access to the other tenant's secrets and keys and so on. That was one side, and the other side was how we dealt with Kubernetes state and how Kubernetes used to do apply. Kubernetes until recently relied on this fat client, which is kubectl, which still has a lot of logic around applying and how you deploy stuff in it. For example, if you do a kubectl apply, what kubectl will do will create a JSON representation of the manifest that you are applying, and it will save that version as an annotation inside the object. So the second time when you apply it does this three-way merge thing where it compares the fields in the annotations with the thing that you are applying with the thing which is in etcd to determine where the changes are. So that made our life very hard, because now you have this problem where if you apply a Grafana dashboard that's a config map, and that dashboard is huge, you'll hit the etcd limit very fast because kubectl duplicates basically all the fields. Also, it's very hard to say, I want to undo only changes made by that controller or by that person, because everything was in a single annotation that got overwritten over time, right? So dealing with building automation on top of CLIs, and it's quite hard. Also with Helm, we had issues with the Helm SDK, which was initially written only for their CLI. It wasn't thread safe. We had a bunch of issues around that. So when we started Flux version 2, the decision was we are not going to do any shell execs. We want to make Flux version 2 multi-tenant by default without having to run an instance of Flux for each single tenant. We want to use, Kubernetes impersonation. And if we don't shell exec to anything, the code is predictable and we can isolate each reconciliation for each tenant. So In version 2, we had to implement all the Git operations in Go using different Go packages, Helm, and we got rid of kubectl by implementing our own applier, which relies on Kubernetes server-side apply. So 1 year ago, Kubernetes decided to move the logic from kubectl in the Kubernetes API itself. So you no longer need this fat client with all that logic. You can send things directly to the Kubernetes API, and the API will know how to do all the merges, all the transformations, and so on. And yes, that's how we truly made Flux version 2 way more secure and multi-tenant without having to run, one Flux per namespace and stuff like that. So that's how we get to Flux version 2, which is no longer a single tool, is more of a platform. Is not only about Git and GitOps, is mostly about continuous delivery, and it also has a companion called Flagger, which can do progressive delivery. Maybe we'll do a talk someday on Flagger. Yes, so we started Flux version 2 2 years ago. It was Hide and me. We start experimenting in the weekend with controller runtime and so on, and we saw that it's easier to secure it if we have different controllers, and it's also easier to contribute to it and reason about code changes when we do the split. So as you can see, for example, Flux version 1 here, we had 275 contributors since the beginning till the end, till we archive it. Now, version 2 is way more younger. It already has 210 contributors because it's easier to, contribute to it. And we also have now a framework where you can extend Flux with other controllers without having to modify Flux itself, which is great. And we saw in our community that companies have adopted Flux just for this aspect. They can extend it with your own things, with your own controllers and your own logic. So now Flux is a multi-cluster continuous delivery tool. Is no longer a single thing. It can span across clusters. You can still run one Flux per cluster to make your continuous delivery, not having a single point of failure. But if you prefer to run Flux on a management cluster, in version 2, we made it possible for Flux to target from one cluster, this cluster itself, so Flux can manage the management cluster, but then it can also connect to any other clusters, or the leaf clusters, or your cluster fleet, and it can connect there and reconcile those clusters as well. So version 2 is more flexible from that perspective. You can deploy one that connects to everything, or you can deploy one instance on each cluster and there lock it down at namespace level and have tenants isolation per namespace. Version 2 is also different in a way that it's event-based. It reacts to events, and not only events inside the cluster, but also events which can came from outside the cluster. So in Flux, we have a dedicated controller, which is called notification controller, that you can register their webhook receivers, and it can, for example, listen to a Git push event and tell Flux, hey, there is a new change in Git, come and get it. Or when you do a Docker push to your container registry, you can tell Flux, hey, go and scan the container registry, there is a new version, and so on. And adding this reactive mode to Flux made it, snappier. It feels like almost like a CA tool, because it can react almost instantly to whatever you do. Don't have to wait for it, like in Flux version 1, when you had to wait 5 minutes or whatever was the whole interval. So that's one major change. Now Flux, deals with events. It also issues events to other systems. For example, Flux integrates with GitHub Actions and with the GitHub API. So GitHub exposes a public API, and you give Flux a secret token, and then Flux can call into GitHub and say, "Hey, run this workflow. For example, promote this Helm chart from staging to production, because I finished on staging and the Helm test has finished," right? That's another feature of Flux where it emits events to other systems. So those systems can integrate furthermore, right? Instead of modifying Flux, you tell Flux, "Hey, call out to this system," and it's up to you there to make other decisions. For example, Weaveworks is working on a pipeline controller, they call it, where you promote things from one environment to another and so on, and it's all based on Flux events. We have many Flux users which wrote their own event receivers of Flux, and they take all sorts of decisions, I don't know, running end-to-end tests or stuff like that. And so that's one side where we added event streaming to Flux. And another thing that we try to do in Flux version 2 is expanding Flux beyond Git as the only source of truth. We'll talk about a little bit about this one. So now Flux is no longer a single controller. There are 6 controllers out there. There is the source controller, which is specialized. It fetches things from outside the cluster. There is a customized controller, which does server-side apply, decrypts secrets, garbage collection, also manages dependencies. You can tell Flux, "Hey, before you install on a new cluster, don't deploy any apps until you deploy Linkerd and you set up Linkerd, and Linkerd is healthy, because when the apps get deployed, they need the Linkerd sidecar or Istio or whatever." Or deploy Kyverno before everything else, because I want Kyverno to verify and all the things that Flux applies, right? So even if Kubernetes is a system where you could just apply all things and eventual consistency, at some point everything will converge and it will be nice, there are some exceptions to it, especially around Kubernetes custom resource definitions. You can't apply, for example, a cert manager a certificate definition if cert manager is not running, and if the cert manager custom resource definitions are not there, its webhook is not there, and so on, right? So there are so many things like that in Kubernetes where you have to define an exact order on how you bootstrap, on how you upgrade an app. Another example is I have to run a job that does a database migration before I can deploy the new version of my app, right? And Flux has this dependency. It builds a dependency DAG, a tree, out of the things that you create, and you can decide in which order things are applied, which things can run in parallel, and which not, right? So that's Kustomize and Helm controller both can do that. As I said, we have notification controller, which deals with events, receives events from outside, forwards events to Slack, Microsoft Teams, everything. And we have the image automation, how you patch things in Git, how you scan container registries. Now there are 2 controllers, the reflector one, which deals with metadata, connects to your container registries, and the image automation controller, which writes changes to your Git repo. And when you install Flux, you can pick and choose, right? Maybe you don't want any kind of image automation. You don't want to allow Flux to write back to your Git. You have some other automation and you make your changes through that. You can install Flux with just source controller and customized controller. If you need Helm, you add Helm to it. Do you need notifications? You add notifications. So it's not all-in-one thing anymore. Like with Flux version 1, you install it, you had all those features there, you had to give it right access to the Git repo and so on. Here it's more you pick and choose, and from a security stance is more locked down in terms of each controller has its own RBAC, its own service accounts, and so on. Here is the Flux team as of this month. Most, but not all of these people are employed by Weaveworks. Most and not all of these people work full-time on Flux, so we have quite a large team. We also have external contributors like Philip Lane from Xenit, which is another company involved in Flux. Early on, they were Flux contributors since version 1, and they have a great expertise into Flux. Their company does consultancy on Azure, Aurel and others, which, people come, people go, but mainly the maintainers are from Weaveworks right now, and we try to invite other organizations into maintaining Flux. The issue with this is mostly on getting, people involved into Flux full time. It's very hard if if your business is not built on Flux. It's very hard to get full-time maintainership and ask people for so many hours for them to contribute. But we are slowly getting there. During the road to graduation, so to say, we consulted with CNCF, and we got to a governance and code of conduct, which encourage other companies and individual contributors to join Flux. We are a welcoming community, I would say. And if you want to contribute to Flux, we are there to help you. We have a dedicated community team, which is looking after our community members. They are organizing meetups. They help us at KubeCon. They write blog posts. They are everywhere, and I'm very grateful that we have the capacity of having a dedicated team that does community management. When you have a large community, it's not easy. It's very challenging, especially for us, as most of the maintainers are in Europe and some in India. So it's quite challenging to be on Slack all the time for US people, for example. You don't want to answer a question after 8 hours and so on. So part of our community team, they are US based, and we can actually keep up with all the activities around Flux around the clock, 24/7 out of 24/7. And I'm very glad we got into this state. A little bit about Flux version 2 timeline. So as I said, we started almost 2 years ago. We recently figured out we need a way for people to install Flux and create a Git repo and configure Flux, synchronize from the Git repo and generate SSH keys and all of that without them having to do things. So the Flux CLI now has a bootstrap command, which you give it a token or an SSH key, and it does all the things for you. It connects to your cluster, it sets up Flux, it configures the repo, it pushes a manifest to the repo, and configures Flux to automatically update. One of the nicest features of Flux since version 1 is that Flux is able to upgrade itself. In the same way Flux manages any other deployment, it can manage itself. And especially with version 2, since we started, we have a very strict backwards compatibility scheme put in place. So we had people that installed Flux almost 2 years ago. They forgot about it. They found out, oh, there is a CV in Flux. Can I upgrade to the latest version directly without jumping through, I don't know, 60, 100 releases or something like that we did in 2 years. And yes, you would rerun Bootstrap and it actually works, and it can upgrade everything on its own. So that's one of the powers of Flux, so to say. It can keep itself up to date in the same way it can update any other application you have on your cluster. And I think that, from a security point of view, it's critical that your continuous delivery tool is up to date and does not have CVEs. If that thing is vulnerable, then anything else will be vulnerable, right? So continuous delivery tool and also continuous integration tool should definitely be treated as part of your production system, and you should look at them with care in the same way you look at your apps or your load balancers and so on. These are critical part of your infrastructure, and what we've seen in the last couple of years is that large companies got hacked because they overlooked a Jenkins server or whatever. So if you install Flux, please look into it. It's very easy to enable auto upgrade. We also offer GitHub actions and other facilities to drive the upgrade operation through pull requests. So what happens is you install Flux on your cluster, then you configure a GitHub action in your GitHub repo. Every time we do a release, that action will open a pull request on your repo. You click merge, and from that moment on, Flux upgrade itself. You don't have to connect to the cluster. Flux can do it from the repo as with anything else. So that's important. Okay, next we got from sandbox to incubation last year. We've expanded Flux to other territory. For example, early on last year in 2021, we made Flux take the desired state from S3 compatible storage. So things like Amazon S3, Google Bucket, Azure, blobs, a Minio cluster, and so on. If you need clusters which can't reach to some Git server outside of your VPC, and everything is locked down, and you have a bucket there regional next to your cluster, you can use that as the desired state. And this also came a security feature request for people that said our cluster cannot reach out to the outside, and what we have available, the only storage is an S3 bucket, and we made that happen into Flux. Also, late last year, Weaveworks started working on a thing called TF controller, which is a Terraform controller for Flux. This year it became quite popular. The idea is you can apply all things that you do with Kubernetes manifest and GitOps to Terraform modules and Terraform scripts, and it works in the same way. It also has the same dependency mechanism in Flux and so on. So if you are into Terraform and you want to provision things outside of your cluster from Kubernetes, check out TF Controller. Is a cool project that my colleagues are working on. Early this year, as I said, we adopted server-side apply, and we have an excellent diff detection and correction. Also, the garbage collection is stateless. So that were major improvements versus version 1. And because we have this, allow people to add new controllers, and Flux is more composable, it's security aware and so on. Cloud vendors started to adopt Flux version 2 for their offerings. Azure Arc comes with Flux, and they build their own controllers on top of it. Amazon, AWS, EKS Anywhere also have a Flux module. They build their own versions of Flux and so on, so you can control deployments anywhere on-prem and also on EKS. VMware Tanzu, Department of Defense has included Flux in their recommendation, and many others. So we've seen major adoption from this point of view, which was a big difference from Flux version 1. Flux version 1 was mainly adopted by organizations for their own continuous delivery platforms. And now with version 2, we've seen that providers are adopting Flux so they can offer Flux as a service to their end users. And even with Flux version 2, we still got the same question from many users and people that looked at Flux and said, oh, I can't use this thing. I need the UI. I need to click buttons. I can't just look at Git. In my mind, I didn't quite see the usefulness of having a UI for a continuous deployment system that deploys things across hundreds of clusters and thousands of apps. Could you look at a UI and click over things? I didn't find it that useful. In my mind, everything should be reactive. If something goes wrong, you get an alert in PagerDuty, or if you want to see what's going on, you look at the Grafana dashboard. But it's clear that a lot of people that want to get started with Kubernetes and continuous delivery, it's way easier to just see everything in a single pane of glass, click on buttons, and inspect things, see all the things that Flux does. And Weaveworks this year has released a product called with GitOps, which has an open source version that comes with a Flux UI, and it's just a Helm chart. You can easily install it with Flux, and you have a great UI experience of all things that Flux does. You can see the events, you can see the versions. If a thing was verified, if it's signed, it gives you a really deep insight into how continuous delivery works with Flux on your clusters. And if you have issues, it's also a great tool for doing debugging. And lastly, what we did this year, we've extended Flux sources to be, so we had Git, we had Helm repositories, the old style Helm repositories, which are HTTP servers, and S3 buckets. But recently, OCI has took off, and people want, instead of defining your desired state in Git, but your actual code being, placed in a container registry, then you have basically two sources of truth. The configuration is in Git, but the actual binary or the compile code or the mimified code is in a container registry. And what we have enabled this year is to make OCI the single source of truth for both code and configuration. So Flux right now is able to fetch Helm charts from container registries which are compatible with the Helm OCI media type. That's one thing, and Flux also is able to verify the signatures of those Helm charts using cosign. But I don't think you should define the whole cluster desired state in a Helm chart. Helm charts are made for apps. They are namespaced object. They should be it's packaging for applications, not your whole infrastructure. You shouldn't put, I don't know, namespaces and tenants and the access control of your users in a Helm chart, in my opinion. Things that are global should come from other places and not being inside charts next to your apps. So what we did with we are turning Flux into a package manager which is focused on OCI. Flux now, like Docker, has a push command where you can say push this directory from your Git repo, and what Flux will do Flux the CLI will package that directory as an OCI artifact. You can also sign that OCI artifact with cosign and push that to the container registry. Then Flux on the server side, source controller, for example, will connect to the container registry where your app is. It will also pull these definitions, which can be customized overlays. It can be plain YAMLs, or it can be Terraform scripts, and Terraform controller will apply them. The idea is that we want to enable a mode in Flux where Git is used for collaboration, but is no longer the place where Flux looks. And this enables better deployments on the edge, Kubernetes on the edge, where you don't want to deploy your Git repo there, but maybe you have a container registry mirror closer to the edge. Or there are so many other use cases where it's better or more secure to reach to a single thing that hosts all your artifacts, a container registry, than reaching out to the container registry to pull container images, but going through Git or an S3 bucket to get configuration. Also, what I quite like about container registries are the way context authentication works, right? Kubelet, for example, is able to refresh the AWS token and connect to ECR without you having to provision a secret on each node, right? It's a binding there, and you allow that particular machine to connect. In the same way, you can use IAM role bindings for service accounts and allow Flux to connect to the container registry, and Flux will refresh the token and will do all of that. So you don't have to, manage secrets. You don't have to keep a secret somewhere with your Docker config, your username and your password. And that, makes it's a good step forward to a better security. And we have many users which, for example, switched from HTTPS Helm repos with username and password with basic authentication to storing their Helm charts in ECR, GCR, whatever, and using Flux with context authentication and authorization, which I think it's a nice feature to have. No more secrets that you have to store everywhere. So that's what we did in the final months of this year. And the best thing about it, we finally graduated. It was 10 months experience when we had to reshape our documentation. We went through security audits. CNCF had interviewed Flux users which use Flux in production, use Flux at scale, to make sure that, okay, this is a a mature project that actually works and solves real issues. And yes, after almost 10 months, we are now a graduated project, and I'm very happy to see Flux here. It's not the end of the line. It's more like from this moment on, we have to do all things on time, and it puts more pressure in a way for us, because being graduated means you have to offer stability from this moment on. No more driving fast and breaking things. So we are also, next year, the focus is to get some Flux APIs to GA, and I'll talk about it. Do you have still time, Saim? Or
Yes, absolutely. We definitely we cover this. We don't want to miss it because that's a big news if people are listening to us.
Okay. So around security audits, this is one of the requirements to graduate. You have to have an independent security audit of all your source code components and so on. And CNCF was very open to sponsor such a security audit. And people from Adalogic, or Steve and Adalogic did this for us. They discovered a bunch of issues. There was one major CV that they discovered around multi-tenancy isolation that we quickly fixed. And from that moment on, after that security audit, we felt like we have to put in place a process for changing things into Flux source code which touch any security aspect of it. So now we have an RFC process in place. Every time you want to, change or add a new API or do things like that, you have to go through this RFC process. It's it takes way more time to add a new feature in Flux or change something that's already there. But I think the process is great in a way that you have to have the community, the maintainers all together and figure out, is this the right way to do it? What other options do we have? Or maybe we should reject this feature because it opens up Flux to some vulnerabilities and so on. And we got so far, I think, 4 RFCs in, which are already implemented. Oh, for example, the OCI feature was shipped through RFCs and so on. It took many months. It wasn't easy, but I think having such a process it's great for mature software which are used in critical environments and so on. We also started continuous fuzzing. We got a sponsorship from Google OSS Fuzz, and all the Flux controllers, all the packages, the source code is continuously fuzzed. We found several issues with it, out of memory problems and so on. So that was a really great addition to Flux in itself. And this year we continue improving fuzzing, and we've improved our test coverage. We added more end-to-end tests for external platforms, like all the things that we do with Azure. Now we run everything, KMS, AKS, everything, right? And we want to get sponsorship from other cloud vendors and do the same thing for all the Flux integrations, because it's very easy to break something if you can't test it in an automated way. And next year we applied for a second security audit. This was mostly because the first audit was based on before we fully implemented server-side apply. Now we have that in, and we really want a security audit to look over our multi-tenancy approach from the server-side apply feature and how we impersonate now service accounts, which is quite different from what we did before. And we are also collaborating with the Kubernetes security working group around the multi-tenancy topic and of course impersonation. Some things general around Flux. So Flux tooling is made out of the CLI, which allows you to install, upgrade, and operate Flux, debug Flux. It has things like commands like Flux diff, which allows you, let's say you make some changes to your manifest or to your customized overlays, and you don't want to commit those changes to see how they will impact your cluster. So for that, we have this command, which is called Flux diff, that runs on changes made on your local machine, but it doesn't apply them. It uses the server-side apply dry run feature, where it does a dry run apply, and then it returns you a nice view of only the changes. So you see, oh, this change means you've added this label, you remove this container, and so on. So you can see before you do a commit, before you change anything, how those changes will reflect on the cluster. And we have also Flux trace command. There are many things we keep adding around debugging. We also have a Terraform controller. So the best way to install Flux is through the Flux Bootstrap, the CLI command. Now, what if you create your clusters with Terraform? You may not want to shell out to the Flux CLI to run Bootstrap. Maybe you want to put there the Flux definitions in your Terraform code. So we maintain a Terraform provider, a module that you can import in your Terraform scripts and do the same things that you would normally do with the CLI. And a third install option is through Helm charts. We don't maintain Helm charts. There is a Flux community maintained chart, which is almost immediately updated and up to date with our latest release if you use Helm for bootstrapping, which I don't think it's great, but for people that want to use Helm, we also have that option. I talked about the GitHub actions for upgrading Flux and driving promotions and all of that through CI. For those that want to integrate with Flux at code level, they want to build their own controllers, or they want to, observe Flux or control it in a way or another, we offer Go clients like Kubernetes does. You import our package, and then you can do all things for Flux objects. We ship with Grafana dashboards for monitoring. And of course, you can install the Weaveworks open source web UI to see all Flux in there. So this is the tooling ecosystem, so to say. This is a little bit about the customized integration already. Told you about dependencies and stuff like that. What's different in Flux to the customized CLI is the fact that we've locked down customize how we run the build in Flux. For example, we do not allow any customized plugins, because customized plugins to shell out, and you can do all things with it inside the container, and we are not doing that anymore. So you can't use customized Helm inflator, for example. You should be using Flux Helm releases. And we also allow cluster admins to turn off customized remote bases and only use Flux sources which are verified, are cached, are subject to policies, and so on. And of course, we do things like if you use a customized secret generator or config map generator, every time you change something there, Flux Customize basically creates a new secret or config map object, which is great. But all config maps and all secrets stick in the cluster if you just use Customize. Well, Flux is able, through its garbage collection logic, to detect and clean up all these objects after it. And other things like variable substitution. We have implemented our own variable substitution in Flux that Flux is able to replace variables anywhere in your manifests. Customize can only do things in some places. Around Helm, as I said, we use the Helm SDK. Flux can run all the Helm hooks, being tests, pre-post hooks, and so on. There is also a difference, an improvement in how Flux deals with Helm compared to the Helm CLI. So if you use Helm CLI to install and upgrade Kubernetes controllers, and chart uses the CRDs directory to deploy CRDs before the controller, what Helm doesn't do at upgrade, it will not upgrade the custom resource definitions. It will only upgrade the controller. So if, let's say, you deploy a controller and the next version adds a new field, the custom resource definition, that field will not be available to you. Maybe the controller will fail, and so on. What we've added in Flux is an option for you to tell Flux, hey, manage custom resource definition upgrades for me. And Flux, unlike Helm, will do the upgrade of CRDs as well. There is also a feature where you can patch the manifest generated with Helm before it installs. It uses the post-render feature from Helm. The idea is a Helm chart, especially the values YAML, can get quite huge. If you want to change every single thing that the chart contains, every field in a deployment, every field in a service, and so on, you'll end up with this values YAML, which is a mess of fields that map everything in all the Kubernetes manifests, and that's not maintainable. You'll end up with a values file of, I don't know, hundreds of fields. It's very hard to figure out what to change where, and so on. So I think a better option is for Helm chart authors to only provide the minimum requirement for values, what the things are mostly likely to change, and all the other things, I don't know, I want to add an annotation, or I want to add node affinity and stuff like that. All these things can come as customized patches inside the Flux Helm release, and we have many users which rely on these patches, instead of going upstream and asking the Helm chart maintainer, please add this thing for me because I'm deploying on bare metal and I need all these other fields that I need to change. Another nice feature of Flux with Helm is that Flux can upgrade your Helm charts in an automated way using Semver. So, for example, you install Nginx Ingress, and you can tell Flux every time there is a patch release of that chart that may contain a CVE fix or something like that, do the upgrade automatically for me. And this mixed together with our GitHub action, you could, for example, let Flux on your staging cluster upgrade charts, not only patch versions, any version. Deploy any version on staging, run the Helm tests. If those succeed, call the GitHub action endpoint, and GitHub action will commit to the repo the new version in production. And that's how you drive promotion from staging to production. That's one way to do it. We also have automated rollbacks. The idea is that you can tell Flux, hey, if the upgrade failed, or if the upgrade succeeded, but the test failed, roll back to the previous version and let me know. And Flux is able to do that. And finally, we also have support for charts stored as OCI artifacts. And we encourage everyone in the Flux community, please move away from HTTP repos. OCI is the way to go, and from a Flux perspective is way more performant. Helm repositories, HTTP ones, have this index YAML file which contains all the charts in your repo with all the versions. It's a huge YAML file that Flux has to parse every time he needs to do an action, and that can be it's a lot of network traffic. You have to load the file into memory and all of that. And it's way better to use OCI because then you just query the OCI tags endpoint and it works out of the box with no performance implications. And finally, Flux multi-tenancy mode. What this means is that you can have a repo or an OCI repo or a Helm chart or whatever that you don't trust that much to be applied on your cluster. Maybe you have a repository that people that push code there or Kubernetes configuration to that repository shouldn't be able to create namespaces or custom resource definitions or delete other namespaces and so on. They should be limited only to a particular set of actions and resources inside your cluster. And how Flux allows you to do that allows you to assign Kubernetes service accounts to your tenants. And a tenant can be represented by one or more Git repos or OCI repos and so on. But the idea is that when Flux reconciles a tenant workload, it will do it under that tenant service account. Then with Kubernetes RBAC, you have the power as a cluster admin to limit what those tenants can place in their sources. So we didn't invent our own authorization or RBAC mechanism. We rely on what Kubernetes already does. And we offer Flux create tenant command, which generates all the YAML for you. And by default, it restricts a tenant to a single namespace. But you can extend that and add more repos, more namespaces, or even give that tenant access to some global resources if you think that's the right thing to do. So there is no such thing as a tenant custom resource in Flux. It's all about having a namespace, a service account, role binding to that service account. So it's pure Kubernetes RBAC. There is nothing special about it. We just offer some tools for you to easily generate this, and we have an example repo on how you can set up Flux for soft multi-tenancy. And we also support hard multi-tenancy, where you assign a whole cluster to a single tenant. Flux runs on the management cluster and targets that tenant cluster and reconciles there only that tenant sources, Git and whatever. Finally, some things about OCI. I was saying that Flux now has a command and looks like Docker on your CI, the Flux CLI. So there is a Flux push artifact command where you give it the OCI URL and the local files that needs to be packaged. Then you can sign the artifact, and on the server side, you create an OCI repository where you tell Flux where the manifests are in the container registry, which cosign key or keys it needs to verify, or it also works with serverless with keyless and can verify signature signed by GitHub or EDC or Google or whatever. And using a Flux customization, you can not only apply what's stored in the OCI artifact, you can also patch it, modify it, and so on. So basically, OCI repository is a drop-in replacement for a Git repository if you wish to embrace this workflow. Okay, we are almost done. Roadmap. So next year, our focus is to get parts of Flux at GA level. First, in Q1, we are focusing on all things GitOps. We have the GitOps APIs, which are Git repository customization, Git receiver, and so on, and all the CLI commands around Bootstrap and webhooks functionalities. And we want to promote this at GA, and we are going to do a Flux 2.0.0 release to mark this. Then we are going to do the same stuff for the Helm APIs, notification APIs, and later on image automation and OCI artifacts. Why OCI artifacts are right at the bottom is because OCI is moving very fast, and the OCI standard is changing. So we would really like to, have more time thinking about what's the right approach for OCI in Flux before we tag it as GA. Because once we tag an API as GA, as in Kubernetes, we are not allowed to make any breaking changes or add, new fields which are required and so on. And we felt like we have lots to do still in the OCI space, and we are going GA first with Git and Helm, which are things that, we've implemented since Flux version 1, is the same idea, the same procedure, and we felt like we got the right ideas here, and we can stamp them as GA. And that was it. Any questions? Oh, I see comments.
Absolutely. That's wonderful coverage of Flux 5 year in, I think, most around 93 or 90 minutes of Flux 5 of not just 5, I think 7 year of Flux journey in 90 minutes. So you covered a lot all about it. But let's just discuss these things in detail. Like, what's the GitOps GA mean for people like end user, the companies? We see a lot of the word used for the GA for the Kubernetes releases. These features goes GA. What the GitOps GA mean for the community and user and the companies?
Okay, so first is how you bootstrap Flux on a cluster. We have now the CLI and the Terraform provider module, which basically allows you to create a repo if it's not there. If it's there, add a deployment key to it, provision Flux on the cluster, and peer that Flux instance with the repo either through SSH authentication or HTTPS with a token, or HTTPS with basic auth, and so on. So we have kept improving this all these operations with Git this year, and we struggled a lot with the differences in Git protocol versions. There is a Git version 1 protocol and a Git version 2 protocol. Some providers like Azure DevOps or AWS Code Commit only implement the V2 protocol, and there wasn't great support in in the Go runtime for it. So we've tried various things, and now we came to the conclusion that we forked the Go Git implementation, and we added support for version 2 there. So what people should expect is by next year that Flux Bootstrap will work the same across any Git provider. It doesn't matter if you have a plain Git server spin up with Alpine or Ubuntu in your house on a Raspberry Pi, or if you deploy against AWS Code Commit or Azure DevOps. It will be the same experience, to work the same everywhere. Once we stamp Bootstrap as GA, that means we can't make any breaking changes to the command itself. We can't add, rename the arguments or come up with other ways of providing a configuration and so on. That's one thing for the CLI. For the server side, for the Flux controllers, like in Kubernetes, this means the custom resource definitions right now are V1 beta 2. They will become V1. And for example, Git repository, customization, and receiver, which is the webhook receiver for Git operations. When you do a Git push and GitHub talks to Flux, it calls an endpoint in the Flux notification controller, and that thing is called a receiver. All these APIs will become version 1, and that means that from that moment on, all the improvements, all the changes that we'll make into the API we will not be able to remove fields, we can't rename fields, or change the behavior of Flux without you having to opt in into it. So we'll only be able to add future flags or add optional fields, and only when you subscribe to that future flag, only then the behavior of Flux changes. So what we basically offer through GA is stability and backwards compatibility. We have no plans on adding breaking changes from what we have today, V1 beta 2 to V1. People that are running right now Flux, Git repos and customization, they will be able to do a seamlessly upgrade to GA once we release it. The GA is, besides the marketing value, it has more of a marketing value in my mind for Flux, because we even between beta versions we didn't broke backwards compatibility. But I can understand how an enterprise user looks at Flux and says, oh, these things are not GA, are not V1, we can't use them, right? They don't look into it, and they don't actually see is that yes, there are like 101 organizations, big one, which use V1 beta 2 in production today. For Helm, GA means we will have to, so we have some improvements that we want to add to the Helm state machine, how we work with Helm state and so on, and those will be major changes into Flux towards a more reliable Helm rollback and stuff like that. And we are also working with Helm upstream around improving this, not only for Flux but for Helm itself. We try to work on them on some SDK changes there. So that's why Helm GA is not in Q1, because we feel like there is more work also to be contributed upstream to improve some things. I think I've lost you for a second. No. All good?
Yes, yes, we are online.
You froze for a second. Yeah, so yeah, and for notifications, so we have this Flux event API where every time Flux does something, it issues a Kubernetes event, but also that event can reach out, as I said, to external systems. And we now, our Flux event looks like a Kubernetes event from all points of view. But we people that are consuming or other tools that are consuming the Flux events, they look for more structured information, like which Git commit caused this change, from which branch, who did, was that commit signed or not, and so on, right? So what we really want to do is expand our event API and offer in people that are writing integration for Flux also a stability of the events API. We are going to create an RFC and we are going to decide exactly how things are being communicated. So you know for sure that if you subscribe to Flux events, you are not going to change the structure, and you'll always be able to determine the checksum, the SHA, the signature, and so on. So this is more work around the community and takes a long time. So that's why I'm saying Q3, or I don't know, could happen earlier. I'm not sure, but right now this is the plan for GA. One last thing that I want to mention is, even if the roadmap is around features that we currently have and we want to make them stable and promote them to GA, this doesn't mean we are not going to have any new feature in Flux from this moment on. New features, even new APIs, can be added to Flux, but they will be added as V1 Alpha 1, and they will be behind the feature flag like in Kubernetes. If you want to use a new API, you at install time or at bootstrap time, you'll have to tell Flux, hey, I really want to use this alpha API. I opt into it. I will add this feature flag to enable it. And from that moment on, you can use that. So it's not like we are, freezing any Flux features. New features will come, but they will be behind feature flags from that moment on. And it's close to also what Kubernetes recently did, where beta APIs are no longer enabled by default. You have to switch them on. So we are adopting the same feature release mechanism, where after we promote everything that we have today to GA, all beta APIs will become opt-in from that moment on.
Yes, absolutely. I think everybody who's listening to us, this will be a wonderful news for everyone, because I think the GitOps is getting more and more important next year. I think a lot of the enterprises look at the tools of the GitOps and get started adopting it. And if I look at the Flux ecosystem as of today, there is so many good organizations in the list, and one of the I think the Azure is investing heavily on the Flux as well. So we can see the cloud provider like Azure and EKS Anywhere. I think you speak during the all the talks. So I think they are investing heavily in the GitOps. This means the GitOps is now the experimental to the production, and people will start using it. I think for them, for those people who are listening and watching to us, the GM means a lot to them. Or for those people as well, and also I will be collaborating with you with the next year, specifically with the GitOps GA release. We can cover this again on the same channel to let people know what they feel about it. And also on the newest topic, like we cover everything. And thank you very much for the wonderful, great overview. I think this is a great year in review for the Flux, not just the year in review, but the 7, 6, 8 year journey. And it's difficult to cover all these details in just one go or 1 and 2 hours. But you did a wonderful job of explaining all these details, like how things evolve, how things move, how Flux V1, how you making it a Flux V2, the most contributor join us as of today, companies adoption. So all these things available. But what do you think, like what are the nearest future? We see one feature that's very I like about a lot, the Flux Terraform controller. And I think everybody watching or listening to us, if they look at the Flux Terraform controller, this lift off all of the burdens from you. But what next? What are the next features you are actually looking at it? There might be some new things coming up, but right now I think the people think about the GitOps for just for Kubernetes. But when the Flux move to the GitOps, it's not just for Kubernetes. You can do all sort of different things with the GitOps and the Flux controller. What do you think what's going to happen next in 2023, not just for the Flux ecosystem but in the GitOps ecosystem? The new tools popping up, because there are two major player in this game is now graduated, Argo CD and Flux.
Yeah, I think the Kubernetes API will live longer than the Kubernetes orchestrator. So I think Kubernetes could be successfully used to drive progressive delivery not only on Kubernetes itself but beyond it, in serverless, in I don't know, all things they can create with Terraform, with Pulumi, and so on. For example, Pulumi has adopted some parts of Flux, the source controller, to fetch Pulumi programs from outside sources and so on. So what I think will happen next year, we'll see more extensions of Flux with different controllers which are not for Kubernetes. And what I think it will also happen is a more all tools will try to get around OCI and cosine and all these things, right, to make the continuous delivery a secure solution and not stitches like it is today. So Flux will definitely, evolve in the security space, and we are going to work more closely with signatures, verification, SBOM, and attestations, and all of that. That's one direction where Flux or possible Flux integrations will cover in the future. And there is also a thing where what I've seen, which is a highly requested feature in Flux, and we should get to it at some point, is the fact that even if automation is great, there are so many organizations out there which require a gating system where it's not technical people which make the decision deploy now this feature or enable now this feature or roll out a new version right now. Maybe he's a product manager, maybe he's a QA team, maybe he's, I don't know, a top management person, and so on, which they don't want to open Git and do some commit and modify some YAML or whatever. So there is a RFC, a proposal that we've made in the Flux2 repo around time gates and manual gates, where you can say, for example, oh, I know that next week my online shop will make 99% of the money it makes in a year, Black Friday or whatever. And you say, in this time frame, no deployments are allowed. No changes to the system. The system must be frozen. No matter if someone commits something to Git, if they change something on the cluster, and so on, right? So it's a way to enforce time-based policies over Flux reconciliation and so on. And the other side is where, even if all things are in Git or in OCI or whatever, you still need someone to approve the final rollout. Let's say Flagger did the progressive delivery, has tested with 5% of the users that everything is good, but maybe someone from the management or whatever, a non-technical person, take the decision, this is not the right time to do it. Maybe I want to roll it back, or I want to prolong the deployment for another couple of days, right? So we need some kind of API which people can build on top of it to create this gating system, which is available to people outside of the technical world, to people that take decisions around the final rollout or stuff like that. So that's where we really want to improve the situation, because we are engineers that build automation, and for us automation is everything should be fully
Yes.
automated and so on. But then you see what some users really want, what their organization culture and policies, that's how they do it, and we should allow them to use Flux in that way. So that's yet one of the things that we try to maybe resolve next year. I know promises.
Yes, absolutely. So one of our common friend is actually also is on the chat as well, Batu developer guy, and also
Developer
Walid
guy.
is saying, thank you, Stefan, for such an amazing talk. It truly is an amazing talk, and Stefan is a truly is amazing person for all the energy behind the Flux ecosystem as well. So, I won't take much of your time. And before I let you go, what is your vacation plan? Where you travel to go? Because Flux is graduated. You've done your hard work. Now you earn your holidays, your vacations.
Yes, yes.
Where your plan? Where your plans to travel now? Travel to go.
Me and my wife, we are taking the dog in the car, and we go from Romania to Greece to visit my family there, and we are going to stay there for, I don't know, Christmas, all the Christmas, New Year's Eve, maybe mid-January. So I'm really looking forward to a couple of weeks break from code, Flux, GitHub, even Twitter.
Yes,
I need a break.
absolutely. You need a break for a very long time, and absolutely, and all the Flux community need a break. So, if you are in the Greece, you can enjoy the party with Stefan, but there is no coding, no GitOps, no Flux, just random talks or a holiday treatment. But thank you very much. Thank you very much, Stefan, for a
Thank you, Saim.
wonderful insight, and I think this would be a
Thanks,
wonderful
everyone.
learning resource for everyone in the future. And we will be meeting again next year for the Flux GA, and plan to cover all these details on the Flux as well. And thank you everyone for joining us today, and I hope you learned a lot from this podcast. And this is your Flux graduation journey, how this project started, and now it's a part of CNCF project. CNCF. So thank you, everyone. Stay safe, stay healthy. We will meet again next time. Bye bye.
Bye.